Alright, so per request, I'm just going to make a video about doing some final exam review. And since we did some examples in class, this won't be as much as far as example problems, but just kind of as a last, or just something to go over more of the concepts of what's going to be on there. So one thing that'll definitely be on there will be, we'll talk about y-intercepts and x-intercepts when given a quadratic. So something like, I don't know, 2x squared minus 4x plus 6, something like that. Alright, and so then to find the y-intercepts, that's when x is 0, or the y-intercept. So you would just plug 0 in for x, right? And so here, I would do something like 2 times 0 squared minus 4 times 0 plus 6, and of course that's 6, and so there's your y-intercept. Alright. However, if we want to know where the x-intercept is, that is when y is 0, so that takes a little bit more algebra. So we would set it up like 0 equals 2x squared minus 4x plus 6. Right. And we would let a be 2, b would be negative 4, and c would be 6. So then we would plug it into the quadratic formula, which is that x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And unfortunately for this problem, I don't think that would work. I think that would be undefined. But anyway, get the idea. All right. And so one of the important parts about this is just knowing that to use the quadratic formula when given a quadratic like this, but also another problem that's going to come up is a quadratic has to be equal to 0. So if we get something like something along these lines, to be able to set this up to solve it, you're going to have to move things over to make it be 0 on one side. So maybe I subtract 3x squared over to here, so I've got negative x squared plus 4x minus 6 equals 4. But then I want to subtract 4 over because I want the right side to be equal to 0. So I have negative x squared plus 4x minus 10 equals 0. Alright. So just be familiar with that, and just understand that you have to solve a quadratic, you have to set it equal to 0. Alright, the next type of problem will be given 2 points, being able to develop a line out of it. So when we have something like x1, y1, and x2, y2, we have to calculate the slope. So you're going to be given 2 points and have to do mx plus b. Right, m is our slope, and it is y2 minus y1 over x2 minus x1. Right. And so once you find out what m is, then you can plug it back into the line equation, or the slope-intercept form. So if, say, I get a slope of, 2, right? So maybe my m is 2. Then I would go back to my slope-intercept form and just plug 2 in for my slope. Then to be able to solve for b, I have to take one of these points and just plug it in. So here I would take maybe y1, plug it in, and then 2 times x1 plus b. Do my algebra, because these will just be numbers as opposed to letters, but just do the algebra to figure out what b is. Maybe we get an answer that b is 4, so then you would just take it back up and plug it back in to say that, you know, the line that goes through those points is y equals 2x plus 4. All right, something like that. All right. Then we want to get into some calculus stuff, so some calculus derivatives. All right, so some calculus derivatives. We want to know things like the power rule. The power rule applies when we just have x to some power. So maybe we have a function, we'll say f of x. So we've got a function that's equal to x cubed. All right, let's make it 2x cubed just so we can see it. All right, so then to take the derivative of that, I bring the power down, multiply it by whatever's out front, and then I subtract 1 from the power to make my new power. So that gives me a power of 2, so I get 6x squared as the derivative. All right. Then we have the product rule. The product rule is with when we have two functions being multiplied together. So maybe like g of x is equal to some u times v. Then the product rule says that we just take the derivative of the first, multiply it by the second, plus the original of the first times the derivative of the second. All right. So that's the product rule. Let's just do a quick example of that. It'll be fun. So maybe like 2x plus 4 times 3x plus 6. All right, so then the product rule would say do the derivative of the first. Derivative of 2x is 2. Derivative of 4 is 0, so that goes away. 3x plus 6 plus the first, which is 2x plus 4, times the derivative of the second. Derivative of 3x is 3. And then you would just do the simplification from there. Okay. Then we have the quotient rule. So the quotient rule says that if we have two things being being divided, so we have, you know, some kind of, we can say u over v, or we can say, you know, high and low, right? So we have two polynomials being divided, and so then the derivative of that is the bottom, which would be low, times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. All right, so that would be the quotient rule. For the quotient rule, you will not be asked to simplify anything. You will just have to get it to this part of setting up the derivative, but no simplification will be necessary. Just as an algebraic note here, two things that happen a lot when taking derivatives. Just know that the square root of x gets rewritten as x to the 1/2. So if I have my function is equal to the square root of x, I have not taken a derivative. Instead, my derivative would become, I'd bring the 1/2 down, multiply it by whatever's out front, which here there's nothing, and then subtract 1 from the power to make my new power, so negative 1/2. All right, so that's a common mistake that I've seen several times over the course of the semester, so just watch out for that. All right, the next calculus topic will be when we talk about increasing and decreasing functions, so trying to figure out if a function is increasing or decreasing. All right, so out of that, we're given a function, I don't know, let's say, let's do 2x squared plus x plus 4. Okay, so we're going to, now let's do 2x squared plus 8x. There we go. That way it doesn't turn into the same problem we ran into in class. All right, so the first step, take the derivative. All right. So I get 4x plus 8 as my derivative. Step 2 would be to set it equal to 0 because that is a critical point. So I'm trying to find my critical points because that's where the potential changes in slope happen. So I'm going to subtract 8 over, subtract 8, and I get negative 8 equals 4x. So I'm solving here. We can call that step 3 if you want to. All right. So I divide by 4, I get negative 2 equals x. All right. So I've found my critical value. So this tells me that that's where some kind of flat spot happens. I don't know if it's a change, but that's kind of what I'm assuming will happen. So I set up my table, and I look on the intervals from negative infinity up to negative 2. And then I look from negative 2 up to infinity. All right. And I am looking at the derivative. Okay. And all I care about is the sign of the derivative at the point I choose. So maybe I choose negative 10. I plug it in to 4x plus 8. That becomes a negative number. I don't care what the number is as long as I know it's negative. So that means that I'm decreasing here. Then I choose a number between negative 2 and infinity, like 0, 100, doesn't matter. But when I plug that in, I get a positive number, so that tells me I'm increasing. So I'm decreasing on the interval from negative infinity up to negative 2. I'm increasing on the interval from negative 2 up to infinity. All right. So that is solving increasing and decreasing. All right, then go into finance. The 3 equations that I had mentioned in class about knowing are, let's see. So one is just the basic compounding interest. Which is in 5.1. Okay. So just the basic compounding interest, which was when we were given a present value of some kind, like a lump sum. We're going to go put $10,000 in the bank and just let it sit there. All right. Let me rewrite finance there a little better. Oh, that's in pencil. All right. The second equation was the amortization one. So it was amortization, and you can find that in 5.3. It's the loan. When we take out a loan, it looks something like it's PMT is equal to the PV times R over N of 1 minus 1 plus R over N to the negative NT. Right? We use this when we want to figure out how much a loan payment would be. So if we take out a loan of $10,000 and we want to pay it back in 5 years with interest, how much would our payment need to be? And then the last one was ordinary annuities. And so the ordinary annuities, that's in section 5.2, so you can find it. But it says if we're making payments into the account, then how much would we have whenever the time hits? So we're making payments into some kind of maybe a retirement account, 401k. We're making payments of $500 a month. Then how much would we have after the allotted time? All right. And so that's pretty well it as far as what I'm going to ask you. I just may ask you a couple different iterations of the same, using the same setups or the same equations. But that's these concepts that I've talked about just stretch as far as we're going to go on this final exam. So just be familiar with these concepts, and then that'll answer any and all questions that would be on there. All right. If you do have any questions, please feel free to email me. As always, have a great rest of your day.